Alright, hey guys, so today we're going to be looking at modifiers and inheritance within smart contracts. Now, Solidity is a programming language where you can import information from another smart contract, and when it gets compiled, it just compiles as one singular one. So obviously, you import different modules just to make things be a bit neater, be a bit clearer, and we're going to show how to do that towards the end of this video. We'll look at modifiers as well, which is, again, it's just another way of keeping your code nice and concise. We'll go on to that after I've explained this little contract that we've got here. So this is a very, very basic one. There's of course a lot of improvements that could be made, but it serves the functionality that we need to show what a modifier is and how to use inheritance. So we've got a first of all, we've got this token balance because we've essentially got our own token. And that takes an address and maps it to an unsigned integer, which tells us how much of this token we have. We've got the constructor function, which gives us who the owner of the smart contract is, and by default the owner gets 100 of these smart contracts. We can check the balance, so this will be the balance of the message sender. We can create a token. Notice that it has to be the message sender for it, the owner, sorry. So by creating the token, we increase it by 1. Burn token, same functionality, just decreasing it by 1, and then send token. So if we deploy the contracts, we'll just have a little look at it quickly. Now, as you can see, the person who deployed it, he's got 100. If I then check somebody else's, he's got 0. He can't create or burn them. And if we go on to now send, so I've just already copied and paste, I've already copied his address. If we go and send him, let's say 5 tokens from the owner, transact. As you can see, the owner's balance has now gone to 95 because we've subtracted the amount that they've sent from his balance. And if we go over to the second account, he's now got 5. So this account will now be able to transact. Quickly, before we go into talking about modifiers, I'm just going to see what happens when we try to send money to, let's say we send 6 to this address from our original one. Let's see what happens. There we go. It fails because over here we've got this assertion that the token balance needs to be greater than or equal to the amount you want to send. So that there doesn't work either. And of course we still got our 5 tokens. All right. So let's look at how we can make this code a bit more concise. Now, the first thing that you might notice is in these 2 create token and burn token functions, we've essentially got the same line of code. We've got this require message saying that it needs to be the owner if you want to create or burn a token. Now, a way that we can make that a bit neater is by writing what's called a modifier. So the syntax for that is we begin it with the keyword modifier, and we'll call it only owner. And within it, we're going to write our line here. So we're going to copy and paste that. Delete that as well, and we need to finish it off with an underscore. So this underscore, I'll go on to explain what this underscore does first after this. But so this is our modifier, and this contains our line of code, which you can now use and essentially enter it into over here just by using only owner, typing only owner after the public keyword. Now, what this does is it tells us, having only owner after the function tells Solidity to use this modifier. And what this underscore does is it imports essentially any code within this function after this line here. So let's go have a look at how this works after we deploy it. So we've got this contract, check the balance, 100 because we're on the owner. If we then move it and try burn token, as you can see, it still fails. So it should say you are not the owner. There we go. And despite not having the code written in this function here, it's still using the same logic through the modifier. Okay, so now we're going to look at inheritance and importing other contracts into this one here and using them together. So again, we've been able to use the modifier keyword to just help neaten and reduce the amount of code we need to write. Now, another thing that we could do is just have a whole smart contract separately, which handles all of this owner business. So if we create a new contract, new file, and we'll just call it owner.solidity. So we're going to need to use the same stuff as usual to start it off, and we'll go contract owner, and within it I'm going to put this constructor function that we want the owner to be the message sender. So first of all, address mess equals address owner, so we're declaring it there, and then the constructor here, that's the owner is equal to the message sender, and we'll also use the modifier in here, modifier only owner. Okay, so this is pretty much the exact same thing that we had in here, except we've just reduced the amount of code. And of course, now this file here can be used globally. We can use this in any projects we want. So we just need to import it. And it's going to be in the same directory. So it's going to be import from /owner.sol. And then to use it, we just need to write is owner. So this here extends the contract and gives it the properties of this owner Solidity contract here. So again, if we compile it and then if we deploy it, as you can see, we've got all the same functionality. So check balance 100. If we go over to the other contract, 0. Can he burn or create tokens? No, he can't, because everything that's within this here has been inherited in this example contracts. So yeah, it's just quite a nice little way of neatening up things, and just cutting down your code, and then also making your code reusable, which is useful in the long run when it comes to when you start developing properly. I hope you learned something from this little lesson. It's quite useful information, all of this here. I think we're going to cover fallback functions soon, and hope you all have a good day.